IT technology has really moved into our business and broadcast. We've seen this with the incorporation of common off-the-shelf equipment that is increasingly, software-based systems on top of PCs and Macs and other kinds of systems, Linux systems and such. And we've also already seen video as file-based media. So if you look at servers, nonlinear editing systems, and so on, they're all basically working with video as file already. So what we're really talking about today is something a little bit different. One thing is if you look at the back of a common PC or something like that, you don't really see much in the way of SDI inputs or outputs. So I think maybe that was missed, but it's not there. But what you do see, right, is LAN, right? So you do see Ethernet connectivity. So this opportunity to use IP, to use CAT, to use Ethernet exists. So what I'm specifically referring to here is real-time video over Internet protocol. So we're really talking about continuing that process of working on top of the technology from IT. We're talking about specifically about streaming media, real-time media, over IP for professional production use, for broadcast applications. Now all this started uncompressed, and compressed formats to do this as well are coming into the mix with SMPTE-SF. But first I wanted to talk a little bit about what was the lure of IP in the first place, and why, what's making us go in this direction, other than the fact that all these engineers are turning out IT nowadays, right? So the thing is that I think it was about 2013, 2015 that it was noted that the typical bandwidth of even, say, the cabling, there's a cable guy in the back, was hitting that point where IT was surpassing what we were doing on SDI. So we're looking at that point about 3 gig or so, looking up toward 12 gig for supporting 4K UHD. But in the meantime, today we're, I think Thomas Edwards was talking about 500 gig, infrastructure today on LinkedIn, and basically we're already 100 gig is fairly ubiquitous. So what about that idea about like using an IP router instead of an SDI router? So there are a lot of interesting things there, not the least of which that the market for broadcast SDI routers is about yay compared to what it is for IP routers. So looking at it a little bit more closely, here's a real example of what an IP router can do with the bandwidth it can support in 11 RU in the same total support in terms of signal flows that we can support in 37 RU times 4. So that's more than an order of magnitude. So when you think about not just the router, but the power and the rack space and the air conditioning and the amount of cable required, you can see why that's a compelling story, not just for a truck, but also for an in-house facility. Example of IP in use, and this is with SMPTE-SF last year. So literally, this is the under-21 soccer final in Krakow, Poland. And 1,000 miles away, this is BT. And they said it was like being there. And by the way, this production was all UHD. So multi-cameras with camera return, everything like that, uncompressed. And they said it was like being there. So it's already in use. And the other thing about IP is the agnostic in terms of the video formats themselves. So in that sense, it's already future-proof. So we're starting to deal with 4K, but what about 8K? What about additional color depth? What about HDR? What about speeds, 60, 120 frames per second, maybe more, 240, whatever. That's not really a problem for IP, especially when we look at that big bandwidth that we could support. The other thing is that when we talk about virtualization, in the past we've been thinking mostly about files and putting things in terms of software, but with SMPTE-SF, with video over IP as real-time media, in that virtualized space we can work real-time. So that certainly adds a lot to the thinking about how do we handle broadcast in the future. So to get there, the Joint Task Force on Network Media worked with a number of organizations in collection to sort of delegate different parts or to ask different groups to do different things. And in terms of this migration, one of the early processes was to go with SMPTE 2022-6, and essentially it was a brute force process where everything, the active video, the audio, the data, everything all in one bundle, if you will, into IP. But even the blanking material in non-active area was also being used. And also the other issue here, if you wanted to do something with audio, not only did you have to depacketize, but you also had to de-embed the audio to get to it. So the additional time and processing and all of that involved was a bit clunky. We needed something more flexible. So the role here of the Video Services Forum was to come up with a concept that was called TR03. And doing that, they used from the industry, from Internet Engineering Task Force, real-time protocol in order to support video as streams, as flows, active video as the request for comment 4175, audio based on the AES-67, ancillary data recently as RFC 8331 that was adopted, that existed for some time, and then for, instead of, let's say, black burst or what we've used in the past for timing, using PTP, again, from the IT world. So all of this combined into a technical recommendation, -03 by VSF. Essentially what we have now is we have independent elementary streams. So in that same situation where we want to deal with audio, we could just grab that flow, do anything we want, change levels, whatever it is that we need to do. It really provided flexibility to what we had before. So the role of SMPTE now was to take what we've done with TR03 and really create standards out of it. So there's a standard now for the overall design and architecture and the timing. There's a standard for how active video, initially for uncompressed video, is handled, a standard for PCM audio, a standard for the ancillary data. So if you look back at that model, basically, we have the overall design of the 21-10. We have the video itself as 2110-20. We have the audio as -30. We have the data as -40. So this all fits into now what is a standard for us to work from. And the value of that in terms of interoperability, I'll come to in just a second. But I just want to mention that already some additional thinking has gone into handling traffic shaping. So this being the -21, and also handling AES, so handling non-PCM audio in this -31. So the role that AMWA, the Advanced Metadata Workflow Association, has taken, they've developed network media open specifications to further build upon what has already been done through the SMPTE 2110 process. And specifically, there's the ISO 4, the ISO 5. The first ISO 1, 2, 3 were really not part of this process. They were for earlier AMWA work. But ISO 4 helps to solve problems of registering and discovering to make the whole process more plug and play, if you will. ISO 5 solves problems that were determined in the process of developing ISO 4 for how we connect flows, how we connect these streams, and how we disconnect them. And Shubha will be talking in a moment about what ISO 6 is all about. So one more organization that's gotten involved in the last year or two is AIMS. So what AIMS is the Alliance for IP Media Solutions, and recently they've sort of been expanded with some other groups that they've joined in with. But basically what this was originally was just 5 manufacturers. But over time, it's become quite a large group of not just vendors, but end users as well. And so amongst all of themselves, they're able to really develop true interoperability and demonstrate it to our industry. So that's really been the key thing that AIMS has accomplished. So for more information, there is SMPTE.org/21-2110. There's the IP Showcase, which was work from AIMS, as well as with other groups like IABM. There's the AIMSalliance.org, and then there's the AMWA.tv, and of course the VSF.tv. So definitely there's a lot of good information about the very specific details that you might have. What I want to do now is to introduce Shubha and to let her talk a little bit more about the specific work of ISO 6. 30 slides.
These belt clips are always a challenge for women. You can do it. Is that good, the volume?
Yep.
Are we good to go? Okay. So I'm Shubha Desikan. I am, I've been with Cisco about 20 years. In fact, it's going to be 20 years tomorrow. And I know many of you, when I hear often in the broadcast industry, people say 20, 30, it seems to be common amongst all of you. But for us, 20 years in a networking company is pretty long. And I don't know whether to call it I've been lazy or what. But one of the things is because Cisco has so many different divisions. And that also gets me to a little bit of my background here. So I have been working on many different industry transitions. So I was in the, in the whole transition of voice when we were going from TDM to IP, and have gone through that transition of not only just voice, but video, and then video conferencing at the higher level in terms of telepresence and everything else. And then I was doing something rich media transition, even in desktop, in virtual desktops with the VDI. And then, of course, a few other things, and then here. So if you really look, there is a pattern here. It's all about taking some applications, rich media applications, especially voice and video, and then bridging it with the network. That's been more or less my role in this 20 years at Cisco. So one of the things that I find is that, irrespective of the fact that, pretty much if you kind of bubble it up at the 10,000 feet level or even higher, it kind of looks almost the same. When we start, we talk about, this IP is not going to be ready, or what, you're going to drop packets, this quality is never going to be enough for me, and so on. And then we transition, and then things change in both fronts, both in the networking side as well as in the application side. And as you know, we no longer have a separate network for voice. It is combined. But there was a time when there was always the thing that no, you can never mix these two networks. They have to be separate, and so on. So it's kind of very interesting. I mean, even though it seems like the same at that 10,000 feet level, I don't operate at that level. I am an architect, so I have to operate at the weeds. And to me, every one of these has been unique. There is new requirements, there is new workflows, and all of this exciting stuff. So at the least I can say is that we are very excited. I'm particularly very excited to be part of this transition that's happening. John spoke quite a bit about the media itself, right, in terms of voice, video, ancillary data, what happened to it, and how IP became ready in terms of 100 gigabits per second and 400 gigabits per second and so on. But I'm going to talk a little bit about the other side, about the control, about management and control, which is really what ISO 6 is about. So I will talk a little bit more about ISO 6, but on the other hand, I will also be explaining the entire workflow of how all of these things fit together. What is ISO 4? What does ISO 4 do? 5, 6, 2110, all of that come together. So I will talk about that. We will first talk about the architecture at a high level so that the rest of the slides make some sense, and then some of the building blocks, and then of course we'll wrap it up with why ISO 6 and what really is the summary there. Okay. Now again, why am I speaking in terms of ISO 6? I am actually, I was the original chair. In fact, I published an API document way back in 2015 and heavily circulated it, and then it became a work group under AMWA, and then Thomas Edwards joined me as a co-chair in 2016, and then just last month in August we published the AMWA IS06. So it was a little bit longer than it should have taken, not unlike any other effort, but in this case it is a very simple and a small piece of work. But on the other hand, it is, and people had to, there was 2110 really sucking up all the oxygen to a great extent, which meant there was less attention and bandwidth available for the rest of the efforts, which I would say really, to a small degree at least, contributed to why ISO 6 took all that time. We talked about cables. I know we have some experts here with cables, but when we take, we saw the change in cables from this coaxial cables to an IP Ethernet cable. But that's not all. What it really brought in there is that it is bidirectional. You can put multiple signals in there, and the very fact that you can put multiple signals in there has some very profound impacts. And really what the impact is that if you had, let's say 10 cables coming in and each of it carried one signal, and if they had to go to a multi-viewer, one of the monitors, to some extent there was no magic involved because every signal was just directed at one particular, workflow. But on the other hand, if now one cable comes in and you are having multiple signals packed in there, and the next packet that comes out, where do you send that packet? How do you know which monitor it belongs to, or Where does it have to be displayed? Now, so you have all these questions that come up, the very fact that you can put multiple signals into one cable. And in order for that to happen, now when you look at that next packet and say, which flow does this belong to, then comes the need for addressing. And when I say addressing, I'm not only talking about the multicast address of that flow, which is what is this flow called, but also who sent it, who is the sender, who is the receiver, because all of these contributes to uniquely identifying that flow so that we know where this flow actually belongs. So the very fact that you have multiple signals packed in there has given rise to some really profound needs that are there, which is really, now I need to know a little bit about control and management and connection management and so on, because it's no longer patching two cables and actually signals flowing anymore. And these, of course, because these cables are frame agnostics and workflow agnostic to some extent, and you can actually theoretically mix live and file-based workflows. In fact, we are doing that in some customer sites. The main thing is that because we have quality of service, because we are used to having multiple signals in a single cable, for example, voice and video, video conferencing, we also have capabilities in terms of quality of service tagging and so on that allows us to really identify certain flows and say that is the most important, you shall not touch that under any circumstance, and then leave the rest of the bandwidth, or the other flows could be on a best effort basis. So to some extent you could use that technology to do a file and live workflows and actually combine it into the same in network infrastructure, which eventually is a savings and capex and so on. I mean, but the thing is that it is true of any migration that we always want to be risk averse in the beginning parts of the migration, right? We just don't want to take some major risks right in the beginning. So it is very natural for us to say, oh, let's keep the file, the infrastructure for the file, the live workflow separate. Please don't touch this infrastructure and so on. But I can bet you that in 5 years we would surely see a lot of convergence of this of the networks between live and other workflows that are there in a broadcast facility. Because this is kind of a general purpose infrastructure right now, it allows us to start thinking a little bit more dynamic in terms of what we can do in the future, and it also allows us to do some newer thinking. So for example, John had a picture here a little while ago where he talked about virtualization. He showed these whole room of racks and so on. So yes, now the first, while I think my area of focus here right now is more about, okay, how does that SDI cable, the coaxial cable change to IP? But then there is the next part, which is, okay, how does these appliances maybe become software? And then once it becomes software, then the next question people will ask you is, does it have to be in my premise? What about if can I put it somewhere else where geographically it can be used in different centers? Yes, that's where the whole cloud thing comes into play. I know the words like cloud and SDN is just, there's ask 10 people, you get 10 different answers. But on the other hand, that's the whole idea, is that you have an infrastructure that allows your workflows to either remain right here on the premise in terms of software, or it could be just anywhere in the world. And so these are the things that, I just wanted to summarize what IP can do for you, kind of like an introduction to when I start to explain why we need anything more than SMPTE 2110. So at a very, very high level, at a system level architecture, I'm just going to kind of put some building blocks and discuss an architecture here. So you have some number of sources, right? And you have some number of destinations. And then you have an infrastructure, which in the past would be the video router, which now is being replaced by what we would call the IP infrastructure. Now, when we talk about the IP infrastructure, it could be just a bunch of switches. It could be a topology that is made of one or more switches, or it could also be that it is not only made of switches, but it also has a network controller on top. And then the other side, other part of it is that there is this broadcast controller. I know I loosely call this the broadcast controller. Very often it is referred to it as that, but I know many of you are from the backgrounds with Miranda and others. Well, I'm sure you know of Grass Valley Convergent, that would be an example of a broadcast controller. So the one that actually manages and controls the network infrastructure. So at 3 levels, I have divided this whole system into the 3 levels. The broadcast controller, it is the one that actually knows the workflows because somebody is sitting on that router panel and making these changes. So it's the one in this entire ecosystem, it is the one that actually knows what needs to happen, which sources need to connect to which destinations. And then there is, there is this network controller. In some cases there is probably not, but if there is a network controller, what it does is abstracts the network while providing the functionality up on top. Now network can get the network can be very complex, if it was a network where you can only do CLI or managing it or something like that. But if you have a network controller, one of the great things is that it can completely abstract all the complexities are below, and it provides a flexible API so that the broadcast controller has the capabilities to do whatever it wanted to do or whatever it has done before. And that particular interface between that broadcast entity, which is the broadcast controller, and the network controller is the network controller API, which is what we will talk here as IS06. Okay. So fundamentally, IS06 is really the interface between the broadcast and the IP network from a control perspective. So when we talk about the workflow itself, it is, fundamentally, yes, we need the flow. So the flow has to get from the source to the destination, one or more destination. That indeed is the main thing, but there's many other things that needs to happen in order to facilitate that SMPTE-2110 to be successful. The first thing is that, okay, where are the devices? Where's the camera? Where's the monitor? Where's the multiviewer? Where are these devices? And which are part of this particular media environment that we are talking about here? And how do we register their capabilities? How do we register who they are and what their capabilities are? This goes back to the point that I made earlier that we do need identity. Identity is a big part of this infrastructure. The second thing is when we talk about the network, like I said, it could be just one switch, or it could be 4 spines and 16 leaves, for example. And if in any workflow you do want to have the capabilities to diagnose, to monitor, to debug, and all of that stuff. And in order to do that, you do need to understand what this network really is all about. So it can be just, oh, that's the IP network, but it has to be like, okay, how many switches are there? How are they connected? And so that part of it is the network topology discovery. I mean, what does that topology look like? And of course, time is a very critical piece of your environment. And the SMPTE-20 IP network is a very open type of network. I can pretty much take the laptops and things like that and connect it into any IP network and start sending and start receiving. It is not very hard at all to do that. And so therefore, it is authorization of the flows. We all need some basic levels of security in that environment. It is not about, okay, this is a monitor, but it went and you are starting to send some flow that it should not really go into that monitor, or take a studio, maybe that studio is not connected to that production control room, but because, we are all humans, we make, things can so on. And like I said before, there's one thing to set it up, but then,